All right, hi there everybody. I am going to talk a little bit about memorizing the unit circle. If you haven't yet watched the video on the left-hand trick, I would recommend you do so. That is really helpful for a lot of people on a way to recall your first quadrant really quickly and easily. Briefly about your angles. So we've talked a lot about the fact that when we're dealing with our radian measure, which is primarily what we're dealing with in this unit, that we have a circumference of 2 pi radians. So this position is both 0 radians and 2 pi radians. And then what happens is that each of our other angles is a fraction of that 2 pi circumference, or the 2 pi first revolution. So when we're looking at half of the circle, that would be half of 2 pi, which is pi. And then the 30-degree increments, which are your pi 6 multiples, they each, since pi 6 is equal to 30 degrees, and every quadrant is 90 degrees, we get 3 of those in each for a total of 6. So this becomes 1/6 pi. This is 2/6 pi, which reduces to the pi thirds. Pi halves is your 3/6 pi. 4/6 pi is your 2 pi thirds, 5/6 pi is your 5 pi 6, and then you hit 6/6 pi, which is your pi, 1 pi, 6 divided by 6 being 1. And then it keeps going. So you add another 1/6, so this is 7/6 pi, 8/6, which reduces, 9/6, which reduces, 10/6, which reduces, 11/6, which doesn't reduce, and then you've got your 12/6, which brings you back to your 2 pi. Then you have your fourths, because your fourths, which is your 45 degrees, you've got 2 45-degree sections in your first quadrant of 90 degrees. So for your 180 degrees, which is half of your circle, you have 4 of them. So this is 1/4 pi, 2/4, which reduces to pi halves, 3/4 pi doesn't reduce, 4/4, which is your pi, 5/4, which doesn't reduce, 6/4, which reduces to your 3 pi halves, 7/4, which doesn't, and then you come to 8/4, which is your 2 pi. So you have to have your angles down first. So now you can use, for your sines and your cosines, your left-hand trick or your special right triangles. So I'm not going to go over the left-hand trick. You can watch the other video for that. But as a reference, our 30-degree angle here across from the smallest angle in a right triangle, which is this 30 degrees, is the smallest side, which is 1 in a special right triangle. And then our other sides are 2 and √3. So this is what gives us a sine of 1/2 and a cosine of √3/2. So we have our 1/2, then we have our √3/2. Then what you should realize is that pi 6 and pi thirds are complements of one another. They add up to 90 degrees, or pi halves radians. And so their sines and cosines are switched. So where the sine of 30 degrees is 1/2, the cosine of 60 is 1/2, or pi thirds. And the √3/2 of cosine becomes the sine value of our pi thirds radians. Now, with symmetry, actually, let's finish up this first quadrant right here. So this is our 45, and that's the one where we have our √2/2 and our √2/2. They're the same because 45 is its own complement. That's why sine and cosine end up being the same, because when you flip-flop them, you get the same values. So now you're looking at using symmetry. So the unit circle is what we call symmetric with the origin. It has both x-axis symmetry and y-axis symmetry. So if I take everything in this first quadrant and I reflect it across my y-axis, what happens is that all of these x's become negative. So this one goes straight across, and this is -1/2, positive √3/2. This one goes straight across. We have negative √2/2, positive √2/2. This one goes straight across, reflects. Now we have negative √3/2, comma, 1/2. Now, each of these quadrants 1 and 2, can be reflected to beneath the x-axis. So you do an x-axis reflection there. And so all of these points going to below the x-axis, all of those y's become negative. So we've got a -1/2. So this one right here reflects to this position right here. So we have a -√3/2 and a -1/2, -√2/2, -√2/2, and then -1/2, -√3/2. Notice too that these two are flip-flopped in the positions. The -1/2 here is the sine, and here it is the cosine. Taking your first quadrant here and reflecting it across the x-axis, all of these y's will become negative. So you'll now have here, this point goes to right there. So you have your +√3/2, -1/2. You have your +√2/2, -√2/2. You have your +1/2 and your -√3/2 using reflections. Same thing works for your quadrantal angles. So with your quadrantals, what we can look at here is this is a point on the x-axis, 1 unit from the origin, because the radius of the unit circle is 1 unit. So x is 1, y is 0. This reflects over here to -1, 0. This point right here, which is on the y-axis, is 1 unit up. So this is 0, 1, and then it reflects down here to 0, -1. So you can do the unit circle that way with reflections. All right. That's all for this lesson, or for this review about the unit circle.